So today we're going to learn of elevation and depression problems. So if you're standing here in a building, you have your line of sight, and that's just looking straight ahead. And so that's what we call line of sight, just looking straight ahead. Now from the top of a building, you may choose to look up, you may choose to look down. If you look up, that's called angle of elevation. And if you look down, angle of depression. So you need to pay attention in a word problem and decide, basically, is the person looking up or is the person looking down? Now what's nice is if you put anything, like say next to a building, a street and a building make usually a 90-degree angle. Not every building goes straight up and down, but most buildings just go straight up and down. So it makes a little 90-degree triangle right here, which means you could use things like Pythagorean theorem, you could use SOHCAHTOA, and they do have devices where you can actually hold them out and it'll tell you your angle of elevation. And so by knowing how high up you are in the building, and you know in your angle of, say, depression, you can figure out how far the car is. So it's a good way to, or you might be standing outside trying to figure out how tall a tree is. So looking up at the tree, if you know your angle of elevation and know your height, you could use that to find the height of the tree approximately. Does that make sense? So what I would do first is always draw a picture. Sometimes they draw pictures for you, which is very helpful. Determine, are you looking up or are you looking down? And then you're going to use trig ratios on this, SOHCAHTOA. Solve it, and then write your answer in a complete sentence, please. So the first problem. A golfer is standing at the tee. That's where, when you have your golf club, and that's the little peg, whatever they call it, and they put it in the ground and they get ready to hit the ball. So the golfer is standing at the tee, looking up to the green on a hill. If the tree yards lower than the green, and the angle of elevation from the tee to the hole is 12%, find the distance from the tee to the hole. Oh, I read tree. I'm like, where the heck's the tree? Okay, there is no tree. Let me reread this with T instead of tree, because there is not a tree. So golfer standing at the tee, looking up to the green on a hill. If the tee is 36 yards lower than the green, so that's where he's trying to hit it. It's 36 yards from here to here. And he's looking up at 12 degrees, that's why they labeled this as 12. Find the distance from the tee to the hole. Now, my eyes are failing me, but it looks like the hole's right here, right? So I would say what they're trying to get me to find is from here to here. All right? From where he's standing to the hole. Now everything's already set up for you. You have your reference angle. So 36 degrees would be A, O, or H. O. That's what you know. You know the distance from the tee to the green is 36 yards. And we're wanting to find, is that H or A? H. So we've already learned this. The only thing new is drawing a picture. So which trig ratio uses O and H? So sine. So I'd say sine of 12 degrees equals O, which is 36, over H, which is what I'm trying to find. Or maybe you used X. I'm just going to use H. Okay. Cross multiply. You get H times the sine of 12 degrees equals 36. Divide by sine of 12, and you get 36 divided by the sine of 12 degrees. Type that in your calculator. I did it last year. I assume I did it right last year. And I got 173.5. Approximately. Well, 0.15 actually. So what does that mean? Well, they said find the distance from the tee to the hole. So I would say, in a complete sentence, the distance from the tee to the hole is what are the units in this problem? Huh? Yeah, yards. Let's put down feet because I'm used to putting down feet, but you got to read the problem. Now, depending on the reason why he'd want to know this is because different golf clubs get the ball at different distances, and so he's going to pick up. That's why they carry a whole sack. He's going to pick up the one that gets it 173 feet-ish. Okay. Now, I don't know much about golf, but I do know you're trying to get the ball in the holes. About all I know. Okay. Anyone play golf before? Mini golf? You ever played mini golf? You should try it. It's so much fun. Try it. Promise you'll have fun. You know what it is, right? Like you try to hit the balls with the windmills and stuff. It's a lot of fun. You should go sometime. All right. So, in this problem, we have a flagpole I can't. Say it's America, that's the best I could do. Yeah. I don't have room for 13 stripes and 50 stars, but that'll be good enough. So, find the angle of elevation to the sun when a 7.6 meter flagpole casts an 18.2 meter shadow. So this is going to produce a shadow. Let's say this is the shadow. And it's 18.2. Okay, so you have the flagpole, you have the shadow. Which usually your shadow is smaller, so I apologize for the drawing. So the question is, find the angle of elevation when a 7 meter flagpole casts an 18.2 shadow. Well, that's basically saying that if this is your line of sight, this would be your angle of elevation. You're trying to find the elevation of the sun, which is basically the angle right there. Does that make sense? So it's a right triangle. And I forgot to label that this flagpole is 7.6 meters. So let's write down what I have. Here's my reference angle. Over here would be O, and the one here would be A. So when you're trying to find an angle, you use the inverse functions. So you say Well, which trig ratio is this? Oh, TOA, right? So the tangent of theta equals O over A, which means take the inverse. And you type that in your calculator and you get 22.7 degrees. So they asked, oh, rounded to the nearest tenth. I did that, okay. So find the angle of elevation of the sun. I would say the angle of elevation, can't spell, of elevation to the sun is 22.7 degrees. It's kind of a weird, usually you know your angle and you can measure the shadow to find out how tall the flagpole is. So this is kind of a different type of problem. Questions? So a ladder with the foot on a horizontal flat surface rests against a wall. It makes an angle with the horizontal. The foot of the ladder is 41 feet from the base of the wall. So basically I need to draw a wall and a ladder leaning up against the wall. So I'm going to do that first. So we'll make a wall. And because I can't draw, I'll say this is a wall. And we have a ladder. Now we don't know if it touches the top of the wall, so I'm not going to assume that, because there's a ladder. And this is really the ground. So now we have a ladder and a wall. Let's fill in what we know. A ladder with its foot on a horizontal flat surface, which is this, rests against a wall, which is that. It makes an angle of 30 degrees with horizontal. The ladder is 41 feet from the base of the wall. So the foot of the ladder would be here. The base of the wall would be here. Does that make sense? So foot of the ladder, base of the wall. Foot of the ladder, base of the wall. They say that's 41 feet. Find the height of the point where the ladder touches the wall. So in other words, what is this? Well, lucky for us, because it's a horizontal surface, this makes a right angle, so we can use our trig ratios. And 41 is our reference angle. I'm sorry, 30 degrees is our reference angle. So X would be my O, and 41 would be my A. So what trig ratio would I use? Tangent. So I would set it up and say tangent of 30 degrees equals O over A. O is X. A is 41. Cross multiply. You basically get X equals 41 times tan of 30. Type that in your calculator. X is 23 point. And it doesn't say how much to round. I usually do 2 decimal places if they don't say. So you plug that in the calculator, you get 23.67. So the ladder touches the wall 23, the height is 23.767. at the point where the ladder touches the wall. Is 23.67. All of our units are feet. Put some of the units in feet, some in inches, some in meters, and make you convert things in feet. This one's going to be fun. So you have this boat. I'm sorry, we should read the deck of a ship. So it's not a boat, it's a ship. It's 15 feet above sea level. It observes that the angle of elevation to the top of it is 70 degrees. Depression level is 50 degrees. Find the height of the cliff. Okay, so we have a ship, we have a cliff. Correct? So we have the ship. This is a ship. Still in last year's ship. That's all that matters. Feel free to. So he's standing on the deck. Probably should draw him a little closer to the edge. And we have the sea down here. This is the sea. And I actually drew the boat in the sea, boat floating over the sea, which I don't see yet. So the boat is in the sea. Now, it is 15 feet above sea level. Any idea what that means? For the first thing, here's the sea level. He is 15 feet above sea level. So what does that mean? Yeah. From here to here is 15 feet. Okay, and again, it doesn't really matter. I should have put the guy a little closer to the edge, but it'll be okay. He observes that the angle of elevation of the top of the cliff, so he has this line of sight right here, approximately, with the boat. I know he's slightly taller. And then we have this cliff. I don't know how to draw a cliff. I'm just going to make a box. So those of you that say you can't draw, look at my drawings. When I can't draw, I just label what it is. That's supposed to be a cliff. So he observes that the angle of elevation, that means he's looking up, of the top of the cliff is 70 degrees. So what he's saying is, if I look right here, this is 70 degrees. Does that make sense? And the angle of elevation of the base of the cliff at sea level is 50 degrees. So when he looks this way, he looks down to the bottom of the cliff, he notices that that's 50 degrees. So if he looks up to the top of the cliff, it's at a 70-degree angle. He's holding some sort of device that says top of the cliff, 70 degrees. He's looking down at the bottom of the cliff, and he's saying at the very bottom, 50 degrees. Find the height of the cliff. And its distance from the ship. So what are they asking me to find now? So what's the height of the cliff? Wouldn't that be, yeah, it'd be this, right? That's one they want me to find, the height of the cliff. And then its distance from the ship would be, I ran out of colors. Oh, I have a green. It's what? Okay, yeah. His line of sight, or down here, same thing, right? Probably easier just to find this. I agree with you. The distance to the cliff, right? Now, lucky for us, this forms a 90-degree triangle right here, and right here, and even down here if we need it. C is mostly flat, right? Okay, I'm missing some information. A man on the deck of a ship. Oh, we need this 15, don't we? So, what if I just label this? If this is 15, then isn't this 15? Isn't it the same? Nice. So I could use this 15 and this angle to find the green. And then once I have the green, I can use this green and this angle to find this, and then I can add those two together to get the total height of the cliff. Does that make sense? So again, I'm going to use this 50 degrees and this 15 to find the green. And once I have the green and the 70 degrees, I can use that to find this piece of the pink. So I'll have this piece plus the 15, which is the total height of the cliff. That's what we're going to do. So first, let's find this, which is distance from the ship to the cliff, one of the things they asked for. So here is my reference angle, right? So I'm going to use 50 degrees. 15 is my O, and X is my